Hi all, we're just going to run through the My Maths work that was set this week. This is the first part of it. And when you first click on the link, so this is the link to the probability introduction. Okay, it will take you to this page and it says please log in to continue. Okay, this login here is just the normal school login. Okay, they've set it up in such a way that it is just Peel and Kites. Okay, when you click login, it will take you straight into the work. So you do not need to use your 4 number and 3-letter password. It is just the school Peel and Kites. Okay, so I'm just going to work through this as if I was a student. So enlarging a photo. This photo has been enlarged by a scale factor of 1.5, 12 centimeters to 9 centimeters. So click next to see the next bit. This means each length on the small photo has been multiplied by 1.5 to give the big photo. So if I times the 12 by 1.5, I would find out what it would be. Okay, what's the width of the large photo? Okay, so times that by 1.5, so 9 is 1 times it, half of it is 4.5, add them together, it gives me 13.5. You can see I've got the sum here, times by 1.5. What's the height of the photo? Again, 12 times 1 is 12. 12, half of 12 is 6. Add them together gives me 18. So 12 times 1.5 gives me 18. We say these two photos are similar because they're in the same ratio. So the ratio of the height is equivalent to the ratio of the width. They've got the same scale factor that we've multiplied them by. They're not identical. They're not exactly the same size. That would be known as congruent, but these are similar. They're in the same ratio. So if we stretched it in the same ratio, it would be exactly in the same in a similar format. Okay. So these two shapes are similar. We can see one is bigger than the other, so it can't be the same. What's the scale factor of the enlargement? So we've got one side that we know that the difference that is the same, corresponding sides, 2 centimeters and 3.6. So if I've got the two sides, to find out the scale factor, I'm going to take the bigger shape, divide by the original shape. Okay, so 3.6 divide by 2. So what's half of that is 1.8. So 1.8 is the scale factor of enlargement that I'm timesing by. So 2 times 1.8, 2 times 1.8 would equal 3.6. Okay. So now use scale factor to work out. So in that sense, I want to know what A is. I'm enlarging it. So I'm going to do, just click on the calculator here. So we're going to do 5 multiplied by 1.8, and that gives me 9. So 9 centimeters is A. And then for B, 4.5 is the long side here, and B here, I don't know what that is. Now to go this way, I'm going to multiply it out, but to come backwards, I'm going to do the reverse. I'm going to divide by it. So I've got 4.5 divide by 1.8. And that gives me 5 over 2. If I press SD, it gives me 2.5. So my answer here is 2.5. Okay. On to the next one. Find the missing lengths on the pair of the sides. So this is your chance to have a go and try it. Feel free to pause the video and then restart once you've had a go. Okay, so this one here will be 20 because I've got 25 divided by 5. So 5 times 5 is 25, 4 times 5 is 20. This one here I've got 28 and 42. This one is 6. How did I get from there to there? I've divided it by 7. So what's this one going to do? Divide by 7 is going to give me 4. This one here is 4 across the top, 5 across the bottom. How do I get from 5 to 44.5? Okay, I'm going to do 44.5 divided by 5. And that gives me 8.9. So my scale factor is 8.9. So I'm going to do 53.4 divide by 8.9. So this one's going to be 6. And then this one here, 4 times by 8.9. So my answer is going to be 35.6. And again, all you're looking to do is, I've got to multiply this by the scale factor to make the bigger shape. If I'm coming from the bigger shape to find this one, I'm going to divide that by the scale factor. Okay, you can tell if two triangles are similar very easily. When a triangle is large, the angles stay the same. Really, really important. So if this is a scale factor of 2, the lengths will get twice as long, but the angles will stay the same size. So that's really, really important. So are these angles similar? Right. Now, what I've got to think is, can I find out a corresponding angle? So that's 52. So we've got 52 that's the same. If we spin that triangle around so it's in the same orientation, the 52 is here. This one could be the 83. And this side is 45. So we need to find the missing angles. Okay, 45 add 52 gives me 97. Take 97 away from 180, that gives me 83. So that makes sense that this is equivalent angles. They are similar. Okay, the sides must be in the same ratio. Okay, because the angles are exactly the same. We don't know what the ratio is, but they must be the same. So let's try this one. These triangles are similar. Find that the angle x, y, z. So x to y to z. So I need to find this angle here. Okay. So looks a bit confusing because the triangles aren't the same way around. So if you imagine we orientate that. So the 62 is here. So we rotate this triangle this way around. Okay, that's the first thing we're going to do. Or alternatively, as they've done here, they've moved the other one the other way around. Okay. Now you can see that CAB, that angle there, is exactly the same as X, Y, Z. Okay, so it's 35 degrees. Again, we don't know what the ratio is. So we're now going to try and find the missing side. We need to do the scale factor. So the bottom one here is 3. This one is 2. Well, I'm adding one more on, so that's half of it. So my scale factor is 1.5. So 3 xy, xy, they've done it on this side. Divide by CA, divide by that side. 4.5, divide by 3, gives me 1.5. So it doesn't matter which side you use. 3 over 2, same thing, gives me 1.5. So this is my smaller triangle. I'm going to go to here, so I'm going to multiply it by my scale factor. 2.5 times 1.5 gives me 3.75, and that is the length of YZ. Okay. 2.5 times 1.5 equals 3.75. Okay, time for us to have a go. Again, if you want to pause the video, feel free. So let's work through. So imagine that that angle is that, if we've got two lines the same like this, that means that angle is exactly the same as this one, and this angle is the same as this. So if we try and spin that round, this side here is the same as this side here. So I'm going to do 13.8 divide by 3. My scale factor is 4.6. So I'm just going to do 4.6 times 2. And that's going to give me 9.2. Next one. That angle is the same as this one here, so this side 29.4 is the same as the 6. I'm going to divide them to find the scale factor. 29.4 divided by 6. My scale factor is 4.9. 4.9 multiplied by the 7 is going to give me 34.3. Okay, and on this one, I've got two sides that I need on this one. You can see this angle here is this one. So this angle, this side 12 will relate to this part. This side here will relate to the 10. So the 18 relates to the 9. Well, 9 is half of 18, or 18 is 2 times 9. So my scale factor is 2. So small side is going to be 2 times whatever this is going to equal 12. So half of 12 is going to give me 6. And on this one, 10 times 2 is going to give me this side, which is 20. Okay, the lines DE and BC are parallel. We can tell that by the little arrowhead. How do we know triangles ABD and ABC are similar? So ABC and ADE. How do we know that they're similar? Well, thinking about parallel lines, if we put a line down here, that angle just sits on top of my parallel line here, which is exactly the same as that angle that sits on top. They're corresponding angles. So if they're corresponding angles, then the angles inside my triangle must be exactly the same. So working it through, draw them out separately. Explain why they are similar. You must show the angles are equal. And again, we can see corresponding angles is what they've done. Put there so you can just have a read through that if you want to. B and D are corresponding. E and C are corresponding. So they must be similar triangles. Now we need to find the scale factor. AD is 8. AB, we don't know what it is. Okay. So we know that that part there is 8B is 14 centimeters. It tells me that on this new one here. So AB is 14 centimeters. AD is 8 centimeters. So 14 divided by my 8 gives me the scale factor of 1.75. Now if we know the bottom, DE would be 5. I'm going to times it by 1.75 to give me that. So 5 multiplied by 1.75 is going to give me 8.75. Okay. To find EC, just this bit from here to here. Okay. First we need to find AC, the whole side. Okay. So AC equals AE times by 1.75. So the whole side is going to be 7.35. And then if we just want the bit at the bottom here, we're going to take away the value of AE, take this bit away from it, and it's going to leave us our ending value of 3.15. Okay, see if we've got time to do this in the last minute. So we're going to show that ABC and DEC are similar. Find the length of DE, so this one here. Okay, so these are opposite angles, so that's got to be the same. So thinking about which way the sides go, we now need a scale factor of A to C, which is 10 divided by 8. They're equivalent sides. Okay, so if we spin this 180 degrees, it would fit into that that shape. So 10 divided by 8 gives me 1.25. We now need to find DE. 12 divided by 1.25 is going to give me 9.6.